In this video, we're going to take a look at titration curves. Now, a titration that you've done in the past has always ended at an end point. So the end point is literally when you stopped doing the titration, and it was because of a color change. And the color change was related to the indicator and the pH range that the indicator changes at. So in Chemistry 20, we titrated vinegar with sodium hydroxide, and phenolphthalein was used, and it went from colorless to pink. So it went from colorless, and when it was light pink, we were in this sort of sweet spot where we ended the titration. Now, that indicator was chosen for us, and if you were doing titration in an actual lab, you'd need to actually know what kind of pH you would expect the titration to end at. So when the acid and base are equal. A titration curve instead continues the addition of the titrant, in this particular case, hydrochloric acid being added to sodium phosphate. And they keep adding the volume past when it's done, and they record the pH. Now, this kind of a curve is typical to see in Chemistry 30, and we need to understand what we're seeing in the curve. So here we're starting with a polyprotic base, so it's able to accept more than one hydrogen. So you've got phosphate ions, and phosphate ions are gaining the hydrogen from the hydrochloric acid. So the phosphate ion plus a hydronium from the acid are going to make a hydrogen phosphate and water. Well, that's what's happening in this first part of the curve. So in this first part of the curve, what's happening is they're adding hydroniums to the phosphate solution and are producing the hydrogen phosphate ion. Eventually, they run out of phosphates, and that's kind of what's happening in this spot. They start to run out of phosphates, and all of a sudden, they're adding hydroniums, and there are no more phosphates to react with, so it's going to be hydronium plus hydrogen phosphate, and you're going to get dihydrogen phosphate and water. And so that's what's happening in this section. But at one certain point, one drop of the acid causes a sudden change in pH. And this is called an equivalence point. And the equivalence point is when the phosphate and hydrogen phosphates are the same amount, or when we've used up all of this hydrogen phosphate and we're going on to the next reaction. So the equivalence point is here. There's another equivalence point here. So the equivalence points are always found halfway through this sort of sudden drop in pH. And if we were doing a titration, this would be our volume of acid that was added, or this would be the volume of acid added, depending on which indicator we selected. So if I want an indicator to select for this equivalence point, I want something that's going to change around pH of 9. So I would pick something that's going to sandwich 9. So phenolphthalein would work for that one. And down here, I want something that's going to change around 4. So if I pick maybe methyl orange, between 3.2 and 4.4, we would expect that the color change would tell us this spot. So when we're selecting an indicator, we want it to sandwich the pH of the equivalence point. And they select those indicators doing this exact sort of process. So once they know the indicator, they can use that in the titration. Now, there are going to be some other things that we want to talk about, which is buffer solutions, and we'll talk about that in the next video. But for right now, a couple of things we're going to see is we're going to see more than one bump, in the curve, that means that we've got a polyprotic something. They're always adding either strong acid to weak base, or strong base to weak acid, or strong acid to strong acid. We'll take a look at what kind of curves those are, but we want there to be a quantitative change. And so they need to have a strong acid or a strong base being added in order for the quantitative change to occur.